In this video, we're going to talk about what limits are. This will be the first time we will see the word limits in the context of Calculus 1. Let's take our basic sequence 1 over n. And let's see what's happened. As we've seen in previous video, when we plug 1, a1 will be 1. When we plug 2, a2 will be half. If we plug 3, it will be 1/3. And things goes like this. And we've seen in the previous video that if theoretically we plug a very big number, let's say infinity, theoretically, plug infinity, a in that place, in infinity place, will be equals to 0. Because we can't plug infinity, because infinity it's not a number, it's something mathematical concept. We write it in this form. Limit or lim when n approaches or reaches infinity of this sequence, it means lim n approaches infinity of the sequence 1 over n is equal 0. So at this point, in this video, I want you to understand this type of writing. When we write that lim of any sequence in the world when n reaches infinity, it means that I theoretically plug infinity instead of n. And what I get if I divided 1 in a very big number, I will get 0. Sometimes we write this like this. You can write it in this form, It's a technical problem. An approaches 0 when n goes to infinity. It's another type of writing, but most of the time we will see this type of writing. Let's take another example. Lim of n approaches infinity. In sequences, n will always reach infinity. Because when we plug another number, let's say 1, 2, 3, not an infinite number, it doesn't interesting because you only plug it inside n. It's not a calculus, it's a regular basic algebra. So what we're interested in is to plug infinity. What will happen if we plug infinity? Let's take this sequence. N plus 1 divided by n. It's kind of difficult example. We will talk about this example in the future videos, how to solve this. But this time, I want you to understand it intuitively. I'm almost sure that many of the people that watching this video know the answer of this sequence. But at this point, I'm telling to myself that I have to teach it very slowly. I assume that you know nothing about calculus, so I'm going to teach you very slow. What does it mean? Limit when n approaches infinity of n plus 1 over n. It means that we have to put here a very big number, like instead of n we plug infinity. It's impossible to do this because I can't plug infinity. But at this point I can find the limit intuitively. I can write this sequence in another form. Remember this rule that a plus b over c, I can write it as a over c plus b over c. I can divide it n by n plus 1 divided by n. N and n cancels each other. It's getting 1 plus 1 over n. Now I understand that if I plug a very big number here, this whole part will go to 0. So 1 plus 0 equals 1. What does it mean? It means that the limit of n approaches infinity of the sequence n plus 1 divided by n is 1. In the future videos, we will learn how to do this. Just understand this intuitively. That's what I want from you in that point. I also can understand why 1 is a right answer. Because feel the numbers. When I look at the numerator, when n is very big, this 1 has no effect on n when n is big. Imagine to you that I'm going to give you $5 and you said to me, you're wrong, you owe me $6. It's a significant difference, it's 20%. Because 5 and 1 is kind of close to each other. But let's say I owe you $1 million, n is a million in this example, and you say to me, I'm sorry, you're wrong, you have to give me $1,001,001. I can laugh at your face because this $1 almost doesn't affect this million. So if n is big, it's much bigger than million because it reaches infinity, we can say that this one has no meaning, doesn't change the n. And we say it's approximately n divided by n, and it's 1. What I showed you here is intuitive approach to find limits. So if one of you find it's a little bit hard to understand those two examples, it's okay. What I want from you to understand at this point is when I want to find the limit, I'm just starting to plug big numbers and see where the number of the sequence are going to. This is, of course, unprofessional way to find limit. And if you will do this in your tests, probably you will get a very low mark because we are just now learning the basics. In the next videos, we're going to start learning how to do limits in mathematical way and how to get a good score in your exams. In this video, we're going to talk about graphical representation of a limit. Let's continue with our sequence an equals 1 over n. We all learn functions in the school. So let's look at the similar function f of x equals 1 over x. I will examine only the positive numbers x because x represents some sort of an n. So I will look only at this side when x are positive. If I draw this function, it will look like this. When x reaches big numbers or infinity, I can see that the numbers of these functions reaches 0. We know the name of this phenomena is vertical asymptote. But we're not talking about asymptotes at this moment. If you want to connect it to this thing, you can do this. So what is n? When n equals 1, I can sample this value on the function. Means that x equals 1 and it's number 1. When x equals 2, I sample this point and its value is 1 over 5, half. If I sample x equals 3, the value of the function will be 1 over 3. These examples demonstrate how that sequence is a samples of the function. When n equals 1, the sequence equals 1. The a1 equals 1. When n equals 2, the number a2 equals half. And so on and so on. So I can see that the numbers are getting smaller and smaller and smaller, and when x will reach infinity or n, of course it will never reach infinity because a theoretical thing, these numbers will be so small that they will touch 0. They will reach 0. After we understand the basic idea of limits, it's time to do some exercises, and we will start doing these exercises in the way that your teacher expects from you to do an exam. So you will understand how to find limits in real pure mathematical way and not like intuitively to plug in numbers and to see what's going on. So let's start our fascinating chapter.